Hello, welcome back to SCI Teach. This is a qualitative analysis video, and we're analyzing a mixture of glucose and copper sulfate. So we're going to carry out the process here and then see how to report it in our report form. Okay, remember to subscribe to this channel, like and share the videos to your friends and your classmates, anybody who is preparing for exam or needs knowledge of these resources, so that as we are learning, they are learning also. All right, let's go. So we have to start by carrying or mixing up the two substances. So here's my glucose. I'm going to put a little amount of glucose into a test tube. Okay, little amount of glucose into the test tube. Okay, since we said this, the analysis is a mixture of glucose and copper sulfate, then we add glucose and copper sulfate to form the mixture of salts. Okay, we're going to mix that and call that C. Okay, so here I add my copper sulfates. Blue color of salt gives you a hint that salt might be copper, because copper salts are blue in color. So if in your exams you see a bluish mixture, your mind is already telling you that maybe copper is present in that solution. So I dissolve my mixture, add water to dissolve the mixture so that it becomes a solution, right? Because we're going to use those solutions to carry out the test. Okay, so if you try to dissolve and it doesn't dissolve, you may need to filter. You may need to use a filter paper and a funnel to separate the residue from the filtrates. But if after adding the exact amount of water, distilled water you were asked to add, it dissolves, then you carry out your practical. You don't need anything, you don't need to dissolve or filter anything. In my case, I think it reasonably dissolves. There's a little solid particles, so but I'll use that, the part that is clear, for my analysis. So it doesn't matter to me right now if it dissolves or not, so I can go ahead and report that it dissolved, because of course you can even see now that it's completely dissolved. All right, it's dissolved. So I can say that C is a soluble salt. Okay, remember C is a mixture of two salts. In your exam condition, you don't know the salt, so I put the two salts and mixed it together and dissolved it, and I found that C is a soluble salt. So I turn out a little amount of C, so solution of C, into another test tube where I will carry out the first test. Okay, so C is in the test tube, reduced into a smaller test tube, and I'm going to start my test. So the first test is with sodium hydroxide. So I'll add sodium hydroxide in drops to this solution of C. Okay, so I add 2 or 3 drops, and you see what forms. A blue precipitate is formed. Precipitates are those things that will not dissolve, but this one is gelatinous. It looks it's not cloudy, but it's like pap. I mean, it's gelatinous, like gel. So I say a blue gelatinous precipitate is formed. Then I add sodium hydroxide in excess. When I add in excess, I see the precipitate does not dissolve. You can still see it inside there, doesn't dissolve. Okay, so even when I shake it, the precipitate just goes up and comes back, doesn't want to dissolve, which means that the ion present in there can't dissolve even in excess sodium hydroxide. Okay, so that is a hint that copper may be present here. You are trying to confirm that there is copper. copper should not dissolve, copper CO2 plus ion should not dissolve in excess sodium hydroxide, and we have seen it didn't dissolve, so we suspect that there is copper, so we write CO2 plus present. But we have to confirm, so in the confirmatory test you have to put turn out a little amount of C also into another test tube. So you say solution of C into a test tube like I've done right now, and this time we're going to test with another reagent, ammonia. So you see my C is in a test tube. Okay, then also in drops, remember, and then you observe what happens, and then in excess. So I'm adding drops of ammonia right now, see, 1 or 2 drops, and my blue precipitate also forms, and it's also gelatinous. So I report that a blue gelatinous precipitate is formed. Now you see precipitate is still there, it persists even when I'm shaking it. So the precipitate does not dissolve in drops. But let's try and see in excess of ammonia if it will dissolve. So I add my ammonia in excess, and it just looks like it's dissolving, but let's see, it's dissolving, and it dissolves. Okay, see, I didn't even have to shake too much, and you see a clear liquid. So that precipitate dissolves completely and forms a deep blue solution. I don't even need to add more, but since it says excess, add a little more, and you see it's a clear solution. So that means that the precipitate could not dissolve in drops, but dissolved in excess ammonia, forming a deep blue solution. That's a confirmatory test. That confirms to you that the ion present here, there is copper CO2 plus ion present here. So you can see the difference between the one produced by sodium hydroxide and the one produced by ammonia. The one from ammonia is darker, it's a deep blue. So report deep blue when it's ammonia, and not deep blue. Don't say not deep blue, just say blue precipitate when you're reporting for using sodium hydroxide. Okay, so we come to our table and report exactly what we just did in that practical. So you see I have test, observation, and inference. Okay, so the first thing I did was dissolve C. I called that solution of 2 salts C, and I dissolved it in distilled water, and then I added distilled water. I can't say I dissolved it because I don't know if it will dissolve. So I added distilled water, and I found that in my case the salt dissolved. So I observed that the salt, or C, dissolved to form a blue solution. Okay, and what does that mean in your inference? That C is a soluble salt. I've said if in your own case it doesn't dissolve completely, doesn't dissolve, and you need to filter it to get the filtrate from the residue, then you observe that C is insoluble. Okay, I mean you infer that C is an insoluble salt. Okay, so we went ahead and added a little solution of, we took out a little solution of C into another test tube. So we write solution of C, and then we added sodium hydroxide in drops. When we added sodium hydroxide in drops, we saw that a blue gelatinous precipitate is formed. We put that under our observation, and then but when we added the sodium hydroxide in excess, the precipitate did not dissolve. So we observe right under our observation, precipitate insoluble. And what does that mean? What does that suggest? What is the inference? We say CO2 plus present. If you want to use maybe present, fine, but you are sure that you've observed, and when you infer, you are saying this is what it is. Okay, you are not saying maybe this is what it is, you are saying this is what it is, but I will test again to confirm if it is what I said it is. And if it is, I will say yes, this is what it is, confirmed. All right, so you just say CO2 plus present. Then we tested with ammonia also. So we dropped that one, took another test tube and added a little amount of solution C to the new test tube and added sodium hydroxide ammonia in drops. We observed also that the blue gelatinous precipitate was formed. That also tells us that, okay, copper is present here. But if I add excess ammonia and it still does not dissolve, then that was not copper. That was not Cu2+. Or my ammonia is very weak, in fact the least weak, but ammonia would still dissolve it in excess. Okay, so we go ahead and do that. After we add drops of sodium ammonia, and so that the precipitate was insoluble, and then we add the ammonia in excess and saw that the precipitate dissolves. So we write it under our observation: precipitate dissolves, forming a deep blue solution. Okay, that is a confirmation that Cu2+ is present. So in our inference, under our inference, we write Cu2+ confirmed. All right, now let's go back there and test for the anion. Remember I said in your own exam you may not be asked to test every single thing in this table. You may not be asked to test for Cu2+, SO4 2-, and the glucose or reducing sugar. You may not be asked to test all three. You may be asked to test two, maybe Cu2+ and SO4 2-, or Cu2+ and glucose. But whatever you'll be asked, I've got you covered, and I've provided everything you need to do to get that the answer that is required. So we finished test for Cu2+, test for copper ions. We found that there is copper in that salt. That's why it's called qualitative analysis. We want to find the quality of that salt. Quality is what does it contain, what does it have. Okay, so you see, number one, it has Cu2+, so we know that's a copper salt. But what is the negative part of this copper salt? Okay, so we are going to test for the negative or the anion. All right, so we go back to the lab. So we add we have barium chloride. We're going to need it for this test. So we take, see, a barium chloride, we take a little amount. We want to prepare aqueous barium chloride because we need barium chloride in liquid form, not in the powder form or anhydrous form. So we take a little barium chloride crystals and we want to try and dissolve it. So we put it in a test tube. Okay, the little amount is okay. It contains the barium chloride. Even if it's the tiniest of it, you would not need to turn a lot of it in. So we dissolve it because we are going to use it to test for the negative ion contained in that salt. All right, so I have my barium chloride solution ready. The aqueous barium chloride is ready for the test. All right, I'm going to use it with that same solution of C. Okay, so I get another test tube, okay, and put that solution of C, a little amount, in it. Okay, so that's my C solution that we dissolved from the beginning. Put a little amount into another test tube. But this time I'm going to test with barium chloride. So that's my barium chloride. Remember that we just made aqueous. So I'm going to put a little amount of barium chloride. Okay, so we see the white precipitate formed. This one is not gelatinous, it's chalky. You see small particles inside that do not stain the walls. I mean, they don't adhere to the walls, they don't stick to the walls, they are chalky. They're like you grind chalk and put in water. That's, we call that one the chalky precipitate. So that's what we have there. Now we're going to try and add an acid to see if it will dissolve that precipitate. So I get my hydrochloric acid. So I reduce my hydrochloric acid into a smaller beaker so I can be able to turn it into the test tube easily. And then I add hydrochloric acid, dilute hydrochloric acid in excess to the solution containing barium chloride and my C solution, and I see that the white chalky precipitate does not dissolve. It doesn't dissolve. Shows me that something is present in this thing, and that thing is sulfate ion. All right, sulfate ion. Sulfate ion SO4 2- does not dissolve in excess hydrochloric acid, okay, and barium chloride. So if it's a sulfate ion, it won't dissolve, and we found out that it's a sulfate ion. That's why it didn't dissolve. Even if you want to use hydrochloric acid first, all right, if you want to use hydrochloric acid first, you have the same solution. So like I'm using now, say I use hydrochloric acid first, not barium chloride first. So I pour in hydrochloric acid into it, say in excess, so I add a lot of it, okay, so that it will prepare the solution for whatever is going to come in. So if it were to be able to dissolve whatever is coming in, as the thing is coming in, it should be dissolving it. All right, so let's see what will happen. The chalky precipitate comes in and stays persistent, doesn't want to dissolve, okay, doesn't want to dissolve. So we have the same result as if we added barium chloride first. So that means this ion present here is actually sulfate ion, because sulfate ion won't dissolve in excess hydrochloric acid and barium chloride. So we go back to our table and report exactly what we found. So we added barium chloride to a solution of C, and we saw a white chalky precipitate formed. There was no gas evolved. So when that happens, before you add HCl, when that happens, there could be a lot of anions that could have been present there. So you have to list them out. CO3 2- would have done the same thing. SO3 2- would have done the same thing, sulfide ion. And sulfate ion, SO4 2- would have done the same thing. So you list out all the ions that would have behaved like this. That is, if you add barium chloride to a solution of mix a solution of salt that contains any of these ions of CO3 2-, SO3 2-, and SO4 2-, you will see a white chalky precipitate that will be formed. It won't dissolve. So, but you have to narrow it down. Which one is it? Is it CO3 2-? Is it SO3 2-? Is it SO4 2-? Because you will not confirm 3 of them. You have to check for a confirmatory test to find which of the 3 ions it is. Yes. So we add excess hydrochloric acid, and you saw that the precipitate did not dissolve. Okay, so you confirm that sulfate ion SO4 2- is present, because CO3 2- would have dissolved in excess HCl, SO3 2- would have dissolved, but SO4 2- wouldn't have dissolved. So that means it was actually SO4 2- that was present that was the anion in that solution. Remember, but for you to score complete mark, for you to score a mark in this SO4 2- you just confirmed, SO4 2- must have been in the list above. That's when you reacted C with barium chloride and a white chalky precipitate was formed. You must have suspected SO4 2- also when you suspected CO3 2- and SO3 2-. If SO4 2- was not there and you all of a sudden confirm SO4 2-, you lose all mark, because you didn't even suspect SO4 2-. Where did you get it from? Okay, so I'm saying it must have been in the first line before you confirm it with HCl excess. All right, so we have reported that second one, second practical. So we have found out that the copper salt is copper sulphate. That means we know now that there is copper sulfate in that mixture. But the question says it's a mixture of 2 salts. So it's now time to find out what is the other salt. We found out that this is copper sulfate as one of them, because we find Cu2 plus ions and SO4 2 minus. If they come together, they form CuSO4. Now, what is the other salt? We get back to the lab to test for the other salt or the other substance. So in this practical, we need 2 reagents. We have Fehlings A and Fehlings B. Fehlings A is the blue one you are seeing. Okay, that's Fehlings A, and then Fehlings B is the transparent one. Ignore the A in the beaker. That was the beaker for the acid I used in putting Fehlings B. So this is the Fehlings B I turned out into that beaker that's labeled A. So the transparent one is Fehlings B, and the blue one is Fehlings A. We need this. Now I'm going to mix proportionally these two to form the Fehlings solution. So I mix them up and form this one in a smaller beaker, which is my Fehlings solution. Fehlings solution is what I will use in carrying out this test. So I get my solution of C, that same C we prepared from the beginning, and pour a little out into another test tube. Okay, so I've poured solution C into another test tube. I'm going to test using Fehlings solution. So I add my Fehlings solution into my C solution. Right? Nothing happens. Nothing should happen until you warm it. Okay, so I'm going to warm it, and then you will see what will happen. So if you warm it in safe conditions, I'm using lighter now to shift it away from where my acid is, because that's the lab. So I had to shift it away from some source of what would be combustible. And what you see, with a lot of heat to warm that solution, it should turn reddish, maybe brownish, but no, we call this brick red. So a brick red solution will be formed. Okay, this brick red solution shows you that glucose is present in that solution. So that was Fehlings solution test for glucose, or test for reducing sugar. So if I react whatever solution that contains glucose with Fehlings solution and warm that solution, the color will turn to brick red, and that is my confirmatory test that was that there was glucose present in there. So we go back to our table and report that. So that's number 5, solution of C plus Fehlings solution. I've told you how to make Fehlings solution. In your exams, they may already make the Fehlings solution mix up for you. So you don't have Fehlings A and B, you already have the Fehlings solution made. Or you have Fehlings A and B, then you'll be given steps on how to mix them proportionally. So I added Fehlings solution to solution of C, and I warmed it, and I observed that a brick red precipitate formed. Okay, that showed me that glucose is present there. So I infer, or under my inference I write glucose or reducing sugar present. So that is everything you need to do if you are asked to do everything. So we know that the mixture of those 2 substances was copper sulfate and glucose, or copper sulfate or any reducing sugar. All right, now in your exams you are going to be given a table like this with spaces. So it's like complete the table. You will see the test and you have to put the observation and the inference, or you can see some tests and you see the observation and you're asked to put only the inference after carrying out the test. Or rare cases, you see the inference and you're asked to put the observation and maybe the test. So you'll be given a table already, and when you see that these tests are what are written there, just remember these are the answers you must supply to have full marks. All right, that is the end of this practical session, and this should prepare you very well for question 2 Waec. Take them very seriously, go through it again and again, and understand how you should report this and what is expected of you. Remember to subscribe to this channel, share this video to your friends and classmates so that they will have a deep knowledge of what is expected from them in question 2 Waec chemistry practical. Also, I've already dropped question 1, which is titration. I've already dropped question 1. You search through the channel, search through the practical playlist, and you will find it, and prepare yourself for question 1. And this is question 2. Question 3 will be theoretical, so you'll be asked things about chemistry practicals, but you have to then write it theoretically. I can ask you simple questions like, why do we have a white surface or a white tile under the conical flask when carrying out titration? You answer, so that you easily observe the color change, okay, when neutralization is reached. They can ask you questions like that. They can also ask you questions that will need you to remember your gas tests, okay? Test for carbon dioxide, test for nitrogen, test for oxygen, test for hydrogen, using a splint, okay? Remember what happens when you carry a glowing splint over oxygen. It rekindles. Or a lighted splint over hydrogen, it makes it burn brighter with a pop sound. Or a lighted splint over nitrogen gas, it extinguishes, puts out the fire, okay? Or how to test for carbon dioxide gas. If you pass carbon dioxide into lime water, it changes the color of lime water from from colorless to milky color. They may ask you questions like that in question 3. They can ask you about fountain experiment. So go and read under chlorine, you will see fountain experiment. They may ask you to report, explain the fountain experiment, state the aim of the fountain experiment, and then they ask you questions to see if you understand fountain experiment. Questions like that are connected to practicals or experiments, but you will just need to write out, not carry out the practical there. That's your question 3. Question 1, titration. We have done that. I've dropped a video, go and check. And question 2 is what we just finished now. Question 3 is what I just explained just now. And those 3 questions are compulsory. If you do all of them completely, you might just be on your way to having an A in chemistry exams. All right, thank you for watching. God bless you.